Well, thanks for those of you guys who have joined us, and hopefully we can make this recording available for all participants to see. But just a quick update, Synopsys, the person, Harish, who was supposed to present from Synopsys, unfortunately could not be with us today due to an emergency situation that he couldn't be with us. So we'll have to reschedule the Synopsys webinar. But we do have Fidel here. He has a really cool tool that he wants to showcase for you guys and tell you how you can get access to it and how you can use it potentially to help with your chip design journey. It's very exciting to have Fidel here today. I'll let him do a better introduction of what I what I do, but I want to give him the time back so he can introduce his cool tool to you guys. Go ahead, Fidel, please.
Yeah, thank you, Professor. You did a good introduction. Yeah, my name is Fidel Makatio Muselebo. I'm a PhD student at Texas A&M. My PhD is focused in analog and mixed signal IC design. So I did direct PhD directly from undergrad, and I did my undergrad back in Kenya, and we didn't do a lot of IC courses. So when I came to the US and I started learning about IC design, it was really hard for me because I had to learn the fundamentals and all those things. I had to understand a lot of concept, and I was also doing research at the same time, so I had to tape out that same year. So end up doing a lot of sleepless nights. Then there came AI. So AI like was doing a lot of changing a lot of things in other fields and trying to cover the knowledge gap. So not just in software engineering, in other fields. So I decided to see how can AI be used to change this knowledge gap, to cover this knowledge gap in the semiconductor field. Because when I was doing it, I needed to do a lot of sleepless nights just to come up with a small chip. So that is how the AutoTapeout tool was born. So I'm gonna just briefly talk about it. So basically, we have trained on our AI to take English prompts. Then that means you just describe the chip, like what the website says here. Say compile chips, not excuses. So just with plain English, describe what you want. Then our AI is gonna take what you want. Then it's gonna go through the entire synthesis flow, then give you an output GDS that you can now send it to the foundry. So this means you don't have to spend sleepless nights like I did, or all those things, especially for quick designs or for companies that just want to prove concept and prove ideas without wasting 6 months. You can just feed it into the AI, and the AI is going to compile it and give you a GDS, and you can now test your ideas or test your circuits, without waiting for my first chip took me 1 year to do because I had like zero knowledge. But with this, you can do weeks. You can have chips ready. So I'm just gonna go over the homepage. So to get here is just autotapeout.com, and like this graphics shows here, you just say describe 8-bit. You just say 8-bit RISC-V processor with UART. Then you do compile, then it generates everything for you, gives you the RTL, gives you the sign off, gives you the DRC and LVS reports, gives you the GDS to download. You can even decide to test it in an FPGA just to make sure, oh, sorry, and so forth and so forth. So this is the entire flow that the current tools support. So from RTL generation all the way to an output at DSC clean. So, and like I said, for those that like using command prompt or terminal, you can just install the tool on your terminal. So, and just be typing normal terminal commands. Then because we are living in a very highly connected world, so the world of OpenClaw and AI agents, so you can now, with our tool, you can actually even use Telegram or Discord. So you don't actually have to install it in your machine. You can send a chat to a Discord or Telegram, then it can do the chip design for you, then give you the GDS later. Then you download it when it's done. It notifies you that it's done like a message. Then you're ready to go. So you don't have to install these heavy software. So you don't have to have a developer grade machine that is usually expensive to do this. So this like covers the knowledge gap and also the resource gap for startups and for beginners in chip design. And yeah, the rest of the thing can be seen in the website. And yeah, currently we are doing this in partnership with Africa GPU Hub, which are providing the GPU resources. So like I said, most of the things I've talked about it. So how do you go about it? So you can say click to submit a request for early access, and you can fill in, you can state your use case. If you're in AI-HDL, you can say AI-HDL, and I will be able to approve that. Another way to do that, which I will do, I will generate the codes at the end of this meeting. I'll send it to Prof. So you can use an access code. So I will generate codes for AI-HDL participants. So you just put the code that when you click join. I had codes for this workshop, but I'll generate others for just for the whole month of April for guys to use. So you can join with an access code, or you can log in if you already have an account. So those are the two ways that you can log in into the app itself. Then there's also a detailed documentation on how to install it in Telegram and Discord. Once you already have an account, it's easy to do that. And it has even detailed prompts in case you want to see the prompt format or prompting format to give you maximum results. So these prompts have been tested all the way to GDS and also simulated an FPGA. So you can go over this, and we keep adding more documentations, and also we'll be adding more and more as guys keep using, and we keep integrating this further to workflows. So I'm gonna quickly go over my dashboard. So once you log in, this is what you're gonna get. Probably I should just put this as an independent. Okay, yes. So this is what you're gonna get as your landing page. So depending on you might not see exactly like this because I've logged in as an admin, but you will see something very, very similar to this. So you can choose the type of work you want. Most people are in standard, but you can choose accelerated or GPU turbo. This is the amount of time you want to be spent in synthesis. So if you have a very complex circuit and you want to spend less time in synthesis, you need more resources. You need 32 CPUs to do the job. Then I would suggest you choose GPU turbo. But if you have a small design, you don't really make use of 32 cores, 4 cores can be enough. Then you just choose a standard one, which is cheaper to use than GPU turbo, especially those that are paying. But for AHDL, like I said, you'll have a code, so it will be no charge for you. Sorry, right now I was in a conference and I was demoing this to Cadence engineers. That's why you see Cadence here. So let me refresh. They made them try a design. Um, so yes. So here you put the name of the design. So you can put something like AI-HDL. Let me put it like that. Then you can describe the design, which you're going to do in a few. Then you can choose your target frequency, depending on what you're designing, maybe your maximum frequency of your transistors, etc. You can choose the die size. Then you can choose the technology. So for now, we're supporting the open source Sky 130, but technically we can support more PDKs, but for now it's Sky 130. Then you can choose for FPGA validation. So for enterprise clients, they get a chance to choose which type of FPGA to validate their design before they get the GDS, so that to be sure that the GDS is working. For most designs that are not complex, probably you can just validate it with looking at the schematic or the GDS or the RTL when it's generated. But for very complex designs like SoCs, like full 32-bit microcontrollers, you might need to validate the timing and everything before you actually send it to the foundry. So you check this part. If you want to have pad frames put for you so that it's ready to go, you can check it. If not, if you want to put pad frames by yourself, you can also uncheck that. Then from here, you can see all the jobs that you did and all of how many were complete, how many failed. You can see the tire. So there is standard tire, there's enterprise tire. So you'll see that. Then you can see the system information here. So currently the LLM we're using, it's a 33 billion parameter model. We're the course of next month, there's a new LLM that is being trained. It's almost done. It's 70 billion parameter. So we're going to put it. So that one will allow you to design for chiplet heterogeneous integration designs and to design AI accelerators because the AI has been trained to design AI accelerators. This one we have right now, it cannot do very good job in AI acceleration and inference chips, but it can do basic and neural processing units if you want, let's say to up to, I think I've tested it up to 20 gigaflops per second because also limited by the technology Sky 130. But the one we're training right now, technically it can do higher than that because of it's being trained, well, 70 billion parameter. I know so being trained to specifically focus on AI compute and next-gen HPC. You can also see the docs from up here. You can also see the jobs from up here. Then there's also another thing. If you want to write your own Verilog, you can just click the Verilog tab and just write the Verilog. Or if after AI has prompted, you can actually come to the Verilog side and you can see the Verilog that the AI has actually generated, and you can modify it in case there's a problem or you want to add more with something the AI missed. We try as much as possible to ground this AI on so that there's very minimal hallucination. And one of the ways is that we have various AI models working together, not just one. So there's an AI model specifically that works to check the output of the first AI model to make sure there's no hallucination. And if there's hallucination, it retries again the generation process. But we also allow the engineer just to check the Verilog generated before the synthesis starts, just to make sure, especially for experienced engineers that have very particular and specific requirements. So also we have IP templates here in case you want to. So I will keep populating these also. So this is not the final one. So these are tested templates. So we have tested this on FPGAs. We have tested it all the way full end. And if you, in case it takes time to generate the prompt, or you just want to use something that is tested, you can just come here and also use the tested prompt. Okay, having said that, we'll now go to the docs. So I'm just gonna use, so you can see the basic how to do the prompting here. So I can copy either of these, or you can, if you already know what you want, you can just describe what you want. But you can copy either of these that have been tested, and others will keep adding more prompts. And I can just call this AI-HDL. Then I'll just paste the prompt. So I'm telling it design a 16-bit UART transmitter with configurable baud rate divider, 8-bit transmitter, FIFO register with full and empty flags, start bit eight data bits, and stop bit. So that's what I want. I'm going to leave everything as default. You can mess around with this frequency if you want, the die size. The only thing you cannot do right now is technology, because you only support Sky 130, the open source one. I'm going to say I need a part frame, and then I'm going to say compile to silicon. So it's going to go over all these steps in the bottom here. So right now it's doing a RTL generation. So the model is actually generating the RTL file of the specific uh, circuit I want it to do. So I chose a simple circuit because of time. Some generation, if the circuit has a lot of gates, let's say 100,000 gates, it's going to take some time for the AI to finish generating, and also the routing process. But hopefully this is a simple medium level circuit that can show the complexity and also be efficient on time, so it doesn't make the webinar a day long. So yes, so it's already done generating. So it's now doing routing. So it's gonna go through all this process and gonna give you the metrics. So it has generated 788 cells for this particular uh, design. Could be more. I've done a design that had like 500K cells, and it took like 6 hours to do the routing and final sign off. So you can do complex designs, yes. And just to mention, for me here, it's showing unlimited compilation because I'm the admin. But for you, depending on your account, you might get maybe only 5 compilations, or maybe 50 compilations because of the resources we currently have. But yeah, uh, mostly the design should be the same. So everything you see here should be close to, everything you see when you log in should be close to what you're seeing currently. But if you see something different, please, you can reach out to me. And if you encounter any challenges into using it, I appreciate feedback for it. So right now it's adding the part frame because I ticked add part frame. If you tick FPGA validation, it now goes and validate before they add in the part frame. It's gonna generate the RTL, then do the FPGA validation, then come back and do the part frame. So yeah, that's gonna take a few minutes. I don't know if anybody has a question.
Thank you so much. It's really cool. It's very relevant to um, our participants, and I believe they would benefit from using a tool like this. Of course, they have access to the open source tools as well as Cadence tools, but this is really amazing opportunity to get, experience with different tools that are available in this area to see which one works best for them, right? And which one is easier to use for them as well. So this is great tool to have access to. Thank you so much, Fidel, for the presentation. Any
Thank you, Prof.
questions
I
from
appreciate
our
it.
audience that are available here? And you can put your comments in the chat or questions in the chat
Yes.
if you have any.
Yes. And just I forgot to mention when it's done, which is hopefully soon. If you wanna view you're gonna get option to download the GDS. If you wanna view it, unfortunately we don't have a viewer here, so you can download the open source viewer K layout,
Hmm.
and it should look like something like this. So this is a circuit somebody from the conference where I am right now generated. So this
Hmm.
is with part frame and everything, but you can zoom in to see your particular GDS and if you want to play around. But the platform doesn't have a viewer. I think it's done. So that one you have to download. The good thing is we have open source viewers. So when it's done, it tells you, of course, utilization because I kept my die size to a very big die. So I expect that. But it gives you the size of GDS, the number of cells it used. It gives you the LVS if it is a match or fail, gives you DRC violations, gives you your timing. So if you met the timing constraints, then you can download the logs, the RTL, or even the GDS. So I'm gonna just say the GDS, and it's gonna start downloading. Yes, there you go. So I'm gonna open it. I think I clicked something else. Sorry. Uh, let's make sure. Yes. So this is the of course we expect utilization to be terrible because of the size I chose, but this is the cells that managed to place and did all the routing. So because it's short, it's small cells, you can go over it by your own eyes. But for complex designs, that's why we have FPGAs, because I don't think anybody can look into 500K cells or 1 million cells or a billion cells. But you can see, go over it, and you can do resynthesis because it's super fast for small designs if you want. And yeah, the only thing you just need to know is how to type in English. Fortunately, that's the only language you support for now. But you can, maybe in future we can do other languages. But yeah, just the only thing you need to know. And you just put it. And yeah, if you want faster speed, you can use all these other options. Or you can even use the templates if you love. Yes. Back to you, Prof. Thank you so much.
Thank you. This is amazing. And I really like to see the GDS2 file coming together. It's really fun.